Hi, this is Miss Sabatello. Hello, this is Miss Sabatello, here to show you how to use a model to balance an equation for a chemical reaction. Here are the directions for today for this activity. You're going to be using bingo chips to build molecules in the reactants and products. You're going to use the colors listed in your packet. I demonstrated this on the first day of the lesson. Again, the key appears in the packet, but I place it here so you can see that yellow represents H, hydrogen, and red represents O, oxygen. This is a molecule of H2, a molecule of O2, and a molecule of water. The first step is to count the number of atoms in the reactants and products. We did this on the first day. So, in the reactants, we have 2 H's and 2 oxygens. How do we know that? We can count the yellow atoms of H, or we can look at the subscript of 2, which tells us there's 2 hydrogens. The same thing for oxygen as well. Then we do the same thing for the products. We see that there's 2 hydrogens from the subscript of H and water, as well as the 2 yellow circles representing H atoms. When there's no subscript on the O, that means there's 1 oxygen, which is shown by the red atom. And we learned that to write a balanced chemical equation, the number of each type of atom and the reactants and products must be the same or equal. We can see that the hydrogens are the same, but the oxygens are not, and neither are the total number of atoms in the reactants and products. So how do we get them to be equal? We add atoms or molecules which appear in the reaction to make the number of O atoms equal. So that means we can only add H2, O2, or water. So in order, we're going to try adding another water molecule and recount the atoms. So in the products, you could see I added another water molecule, and then we recount the atoms. So I only changed the products, so I'm only changing my count in the products. I see now there are 4 H's, and there's still 2 O's. There are now 2 O's, should I say, sorry. So now the 2 O's are equal, but the H's are not equal, okay? So you'll see in a future slide, I am going to put a 2 here to represent that I drew 2 water molecules. I will place a coefficient of 2 here in a future slide. So now what we're going to do is we're going to add atoms or molecules which appear in the reaction to make the number of H atoms equal. So we can't just add H because H appears as H2 in the reaction. So we're going to add another H2 molecule in the reactants and recount the atoms. So I can see here I have 4 H's now, and that matches or equals the 4 H's in the products. They're the same. So now all the types of atoms in the reactants and products are equal, but also the total number of atoms in the reactants and products are equal. So the coefficients are 2 because we made 2 H2 molecules in the reaction, and we also made 2 H2O molecules. Notice there's 1 O2 molecule, but we leave that blank and we assume there's 1. The law of conservation of mass states that atoms cannot be created or destroyed. So what this means is that the number of each type of atom in the reactants is the same as in the products, and that the total number of reactant atoms equals the total number of product atoms. So this is my chart where I counted the reactants and products in my final balanced equation, as well as the total number. 4 plus 2 is 6, and that's equal in the reactants and products. So have fun building molecules and balancing the equation using the bingo chips. Please let me know if you have any questions. Thanks for watching.